Welcome students. Today we will discuss the thermal property of heat and second part. As we know, there are three different mode of transmission of heat. We already read about the conduction. Now we will discuss today about the convection and radiation. Before starting convection and radiation, let us recapitulate about the conduction. When we heat a metal strip at one end, the heat travels to the other end whenever heat whenever we heat the one end, then what happens? The particle vibrates. These vibration makes the adjacent particle to vibrate, and so on. The vibration are passed along the metal so that it heated. If we heat from this side, if we provide the heat from this side to the metal rod, the vibration of the particles gives the energy and the heat will come to the other side. And we call this as conduction. Now, if we consider about the metal conducted with other way, the outer electron of the metal atom drifted and they are free. They are free to move on the metal surface. When the metal is heated, a metal is heated, then the electron gain the kinetic energy. The electron nearby will gain the kinetic energy and transfer it throughout the metal. Wherever this electron goes, it will transfer the heat throughout the metal. But in case of insulators such as wood and plastic, do not have this sea of electron. That's why they do not conduct heat as well as the metals. For example, if we have two rods of wood and metal and both are at same temperature, why does metal feel colder than wood? This is the question for us. The metal is a good conductor and wood is insulator. The metal conduct the heat away from our hand. The metal will conduct the heat away from our hand because the metal is a good conductor. So heat is transferred from our hand to the metal easily, whereas the wood does not conduct the heat away from our hand as well as the metal. so the wood feels warmer than the metal. Now, is second mode of heat transfer is the convection. What happens to the particle in liquid or a gas when we heat them? Here we heat the liquid or the gas. Here are the molecules of the liquid or gas. The particle spread out become less dense. If you provide heat to the liquid or gas particles, the particle spread out after gaining the kinetic energy and they became less dense. Now they are far from each other. This affects the fluid movement. Fluid means which can flow, that is either liquid or the gas. So the fluid movement will be affected by the heat. Now about the fluid movement, the cooler molecules are more dense and fluid sink through warmer, that is less dense fluid. In effect, the warmer liquid and gas rise up. The cooler liquid and gas sink. Here we have the different type of molecules having different temperature. The hotter molecules are less dense and they will rise up, whereas the cooler molecules or the particles of fluids are closer to each other and they are more dense than the hot one, so they will sink. Now let us consider about the water movement. Here we are providing heat through the burner to the water. The hot water molecules rises up, whereas the cool water molecules sink, because the hot water molecule becomes lighter, less denser, and the cold water molecule are denser and they will come down. The hot molecule of water cools on the surface of the water. So this process is regularly happening and giving the convection current. The arrow of the molecules are showing the convection current. Similar, the example here, why is it windy at seaside? The land is warmer than sea. So the land warms the air above it and the air rises up. The air rises up and they become cooler after some time and they will come to the again toward the sea. And this process is happening and thereby there is a windy at the seaside. Another example of convection is the refrigerator, where freezer compartment it put in a fridge on the upper side. It is put at the top because the cold air sink. The cold air sink so it cools the food stuff on the downway. The food stuff on the downway. Here we are putting the food stuff, and the food stuff is cooled, and the cooling is on the downway. And the food stuff warm the air particle. It means the energy of the food stuff is taken by the air particle, and they became lighter, and lighter warm particle of air will move up, and they will produce a convection current. So a convection current is also inside the fridge. Now what happened here? We have sun, which is ultimate source of energy to us. The sun is giving energy, and the energy is coming to the earth. But there is no particle in between them. Between sun and earth, there is no particle. There is a vacuum. So the conduction and convection is not possible. Because for conduction and for convection, the particle are needed. So this is the third mode of transfer of heat, which is different than conduction and convection, and it is called radiation. Now what is radiation? It is the method of transfer of heat from one place to another. From one place to another, in the form of electromagnetic radiation. We know the electromagnetic radiation does not need any medium. So electromagnetic wave transfer the heat without necessity of medium and without affecting the intervening medium. If there is medium in between, then it will be not affect the electromagnetic radiation. Radiation is emitted by an object on account of its temperature. In general, the infrared radiation part of the electromagnetic wave is the major component which take part the heat radiation. So heat from sun comes to us through a radiation. If we stand near the fire, we feel hot, or heat comes to us through radiation. Now sun is providing the heat, and a person is sitting on the ground. The person is sleeping on the ground. What happened? The energy is transferred from the sun in form of radiation, electromagnetic radiation. And this radiation is coming to the person, having area A. The component of the area A cos theta, the component of the area is A cos theta, is the area which is normal to the radiation. This cos theta effect is also responsible for seizure. It means whenever we consider about the area which affected by the radiation, we will take the concept of normal radiation. So we will have a component of area on that side, that is A cos theta. This cos theta is also affected the responsibility for the season. Here we have two different position of Earth when it is revolving around Sun. The axis of rotation of revolution is inclined by 23.5 degree. So the concept of area comes out here. We will have to consider only the normal radiation. So 23 degree will be responsible for the season on the Earth. In next figure, we are taking the month of June. The angle of inclination is 23 degree of Earth through its axis. Then the summer will comes when theta is equal to 0, because cos 0 is 1. Whereas if theta is 50 degree, it means the area with normal radiation is having angle 50 degree, then it is winter. And at pole, the angle is 90 degree. So cos 90 is 0. So there is no radiation here. So it is cold. Whereas when angle is more than 23.5 to 50 degree, the normal component of area is lesser, so there is a winter. Now, the basic characteristic of thermal radiation. What are the basic characteristic of thermal radiation? Number one, radiation is fastest mode of heat transfer. In this, energy is transferred along the straight line, because electromagnetic wave always travel in a straight line with the speed of light. So radiation is the fastest mode of heat transfer. Second property, that is second characteristic, is they require no medium for their propagation. They can propagate through vacuum too. They do not heat the intervening medium through which they pass. The electromagnetic radiation is coming with a speed 3 into 10 to the power 8 meter per second, and they will able to travel in vacuum as well. And if there is any medium in between, so when electromagnetic wave passes through the medium, the heat is not affected. The heat is not affected. The radiation is not affected. they obey inverse square law. It means as the distance passes, the radiation passes through the source, the intensity of radiation varies with inverse square of the distance from the source. The radiation can be reflected, refracted according to the law of reflection and refraction of light. Like light radiation, these radiation also exhibit the other property, other phenomena like interference, diffraction, and polarization. So this is the basic characteristic of thermal radiation. Now let us consider some statements which are true or false. The first one is the radiation travel in straight line. Yes, the radiation is travel in a straight line, that is true. Radiation can travel through a medium as per property or characteristic. The radiation can travel through a medium, it does not need any particles. Radiation requires particle to travel? No, it does not need particles. Radiation travel at the speed of light? Yes, the radiation travel with the speed of light 3 into 10 to the power 8 meter per second. Now the application of radiation, the thermography, the detailed measurement of radiation from the body. The body also radiates energy in form of radiation, and this is used for medical imaging. The radiation coming from our body is used for medical imaging. Warmer area may be seen as tumor or infection. The cooler area on the skin may be sign of poor circulation. So thermography is also used in medical imaging with the help of radiation. When thermal radiation incident on a body, it may be partially reflected, refracted, and absorbed. Let us consider here we have a body, and the thermal radiation is falling on them. The thermal radiation is falling on them. When this radiation falls on the object, some part of the radiation reflected, some part of the radiation reflected, and some part of the radiation is transmitted. They will follow the law of reflection and law of refraction as well. And some part of the radiation is absorbed. some part of the radiation is absorbed by the object. So, if Q amount of thermal radiation is incidenting on the body, if we say the Q amount of radiation is incident on the body at a time, R is the amount of thermal radiation reflected by the body as shown in figure without any loss of time. It means it is instant. And amount of absorbed radiation is represented by A, and T is the amount of thermal radiation transmitted by the body in same time. So the radiation energy Q is equal to R plus A plus T. Now if we divide the equation by Q in both sides, then what we will get? We will get Q by R, Q by Q is equal to R by Q plus A by Q plus T by Q. Now, first of all, we discuss about the first part of Q by Q is equal to R by Q plus A by Q and plus T by Q. The first part is called reflectance or reflecting power of the body. The body is reflecting the radiation Q and the ratio of amount of thermal radiation reflected. R is thermal radiation which is reflected by the body in a given time to the total amount of thermal radiation, that is Q, and it is represented by small r, and this small r is called reflectance of the body or reflecting power of the body. The second part is absorption, that is absorptance of a body. It is the ratio of amount of thermal radiation absorbed by the body in a given time to the total amount of the thermal radiation, that is A by Q, and it is represented by a small a, and it is called absorptance or absorbing power of the body. So it is absorptance or absorbing power of the body. Now third is the transmission. The transmittance or transmitting power is represented by T. Transmittance of a body is defined as the ratio of the amount of thermal radiation transmitted, the thermal radiation transmitted to the total amount of thermal radiation that is T by Q. T by Q. And it is represented by a small letter of t. So from above equation, we have Q by Q, that is 1, is equal to R by Q plus A by Q plus T by Q. That is small r plus small a plus t is equal to 1. Reflecting power plus absorbing power plus transmitting power is equal to 1. So addition of reflectance, absorptance and transmittance is always 1. The reflectance, that is R, of the object, the absorptance A of the object and transmittance T of the object is depend on the nature of the surface of body. What type of surface the body is having. And second is wavelength of incident radiation. It means the surface will affect the reflectance, absorptance and transmittance. The surface is responsible for effect on reflectance, absorptance and transmittance. And the second is, it is the wavelength of light radiation which is falling on the surface. Now let us consider here a body having a nature that it does not transmit any radiation. The body, the wavelength of radiation is lambda and the radiation is falling on this. What happened here? The body reflects the light radiation, some part, and other part it absorbs. But it does not transmit. So we will say the reflectance is there, the absorptance is there, but the transmittance is 0. The object is not transmitting the radiation. So the equation becomes R plus A is equal to 1. Now in second example, if we have an object and the radiation is falling on them, and this object has a property that it does not reflect, that is R is equal to 0, does not transmit, that is T is equal to 0, and it only absorbs the radiation. So in this condition, the A will be equal to 1. Because R plus A plus T is equal to 1. R is 0, T is 0, so only the absorptance is there. It means the whole radiation is absorbed by the surface of object.